Hi class. So I know we've already looked at geometric sequence. Now we're looking at series. So series is when you see a set of numbers like 2, 4, 6, 8, it's adding all those numbers together. Sometimes we may only know the first number and the last number. Let's go ahead and take a look. Geometric series, it's adding up all the numbers in the geometric sequence. So based on what we have is what formula we're going to use. So let's go ahead and take a look. Let's say we had a problem and I don't like those numbers. Hold on one second. Ew. Sure, I like that better. Okay, so let's say we start off with 1 brick, right? And then each time it doubles. So the first layer has 1, the second layer has 2, the third layer is going to have 4, the fourth layer is going to have 8, so on, right? So every time it doubles. So our first term is 1. Our common ratio is 2. And we're going to be looking at 10 rows of bricks. So we want to know how many bricks total. So let's say these are the first, row 1 of bricks, row 2 of bricks, row 3 of bricks, row 4 of bricks. So the first row has 1, second row has 2, third row has 4, and then fourth row has 8. So the next row is going to have 16. So every time it doubles. So instead of figuring out row 1, row 2, row 3, row 4, row 5, and counting all of them together, what's row 1 plus row 2 plus row 3 plus row 4, we're going to use this equation on the top. So we know our A of 1 and our N. So the sum of our bricks, so S, the sum, is equal to our first term, which is 1, minus our first term 1 times our R, which is 2, to the power of N, which is 10, all over 1 minus R, which is 2. Okay. Let's simplify what we can. 1 minus, we can't do subtraction yet, but we can go ahead and do subtraction at the bottom. 1 minus 2 is -1. 2 to the power of 10, so clear this out. 2 to the power of 10 gives us 1,024 times 1. I'm not going to do times 1. 1,024. So 1 minus 1,024 gives me -1,023 divided by -1. It's going to give me 1,023. So if we had bricks, they'd be 1,023 bricks. Okay. I'm going to give us another example problem. Okay, so let's say we don't know how many rows of bricks we have, okay? Okay, we have no idea how many bricks we have, or how many rows. All we know is we have a pile of bricks for the pyramid. Okay, and then that pile of bricks, we know that there's a total of 262,144 bricks in the last row. So we can just count the very bottom. I don't know what row it is. I just see the very bottom, and someone is able to count how many we had at the bottom. $144 bricks. That's just the last row. Okay. So we need to know the sum of all rows added together. I don't know how many rows, but I do know the last row has 262,144. I know that my R is going to be 4. I know it multiplies by 4 every time. And I do know my first row has 4 bricks. Okay, so I'm going to use the second equation. So S of n is equal to A of 1 minus A of n times R over 1 minus R. Okay, so A of 1 is 4 minus 262,144 all over 1 minus 4. Oh, there's 4 twice. It's kind of confusing. That's okay. Okay, so times 4. So let's do our 262,144 times 4. So that's 1,048,576. Okay, divide that by 3. Okay, divide it by 3. That's going to, negative 3. All right. So hold on. Darn it. 4 minus 1,048,576 equals divided by negative 3. Gives me 349,524. So the total number of bricks in the pile is going to be 349,524. And that would be your final answer for that problem.